Hello there. I'm here in our library, and I got a really special guest with me today. We're going to see our special guest in a moment, but today we're gonna study Newton's method. All right, and Newton's method is, well, you know what? Let me have my special guest help you out here.
Hi, I'm Newton. I invented calculus, and my method, Newton's method, is a way to estimate the zeros of a function.
See, I bring in special guests here. So Newton's going to help us out. And he says, you know what, take this function. We're going to estimate zeros using tangents. Right, Newton? See? Okay. So the way we're going to do this is we're going to iterate. We're going to have 3 iterations of NM. That's Newton's method, by the way. I just got a little lazy. So it's going to be N is our amount of iterations. So we're going to have 3 of them. Make a little table here. All right? Then we're going to have an x value that we're going to guess at. We're going to try the function at that x. That's usually the y value. All right? Then we're going to have the derivative of that function at the x value. Then the hardest one, I guess it's hard, I don't know, is f of x of n over the derivative of f of x. I don't know where I got the n from. 2 different notations. Sorry, Newton. Newton, don't leave me. Don't leave me. You're delicious. All right. And then our last one is we're going to subtract the x from that value. There's 2 different problems here that I could ask you. Newton's having too much fun, I think. Okay, we're back here. Newton was having too much fun, and I think was diverting you from everything else. Say bye, Newton. So we have something that looks like this. Now, the goal of this is to tell you how many iterations it's going to be. So this tells me 3 iterations. Sometimes it'll say to get within a certain amount, like 1,000th, 0.001, 2,000ths, all right, 10,000th. So that's what we're going to do. So my first iteration, I'm going to guess 1. Why? Because I said so. Okay. So I'm going to guess 1 as my x. So when I plug in 1 into that function, I get -1. All right? Now when I need the derivative. So I'm going to take the derivative of this thing. Derivative of this thing is what, Newton? Oh.
2x.
All right. Newton says 2x. So we're now going to plug in 1 into that. And we're going to get 2. Now I'm going to divide these, and I'm going to get -0.5. Most of the time with Newton's method, we use a calculator. But back then, he used an abacus, which he didn't bring along with him today. Okay? Calculator. Newton. All right. So then when we take these and subtract it from x, we're going to get 1.5. You might say, 1.5? Why 1.5? Well, because remember, subtracting a negative. Okay? I don't know why I went to red, but we did. Our second iteration, now we're going to use this new x, 1.5, and we're going to go with that. We're going to plug 1.5 in to this equation. We're going to get 1.5 squared minus 2, and we're going to get 0.25. I'm getting nervous. All right? Then we're going to put that into the derivative, I think. We're going to put 1.5 into derivative, and we're going to get 3. Then we're going to divide the 2, and we're going to get 0.25 divided by 3, is we're going to get 0.083 repeating. And then when we subtract that from 1.5, we're going to get 1.416 repeating. Well, now we're going to take our third iteration. We're going to take 1.416, if you will, and we're going to plug it into the original function, and we're going to get 0.006 or 7, 007. And Newton loves it. All right. So then, when we plug that into a derivative, we get 2.833. It goes on for a while. And then when we divide them, we get 0.00245. Okay? 3 decimal points are fine, believe me. And then at the end here, we get 1.414 whatever. Ooh! That looks like the square root of 2. I bet you that's getting very close to the square root of 2. All right? But I did 3 iterations, and that's what I got. You have 2 problems on the sheet I gave you to do. All right? You have 2 problems on the sheet I gave you to do. Also, including these. Page 233. 1, 2, 7. All calculator based. All right? And 21. And then I'll do 41 to 44, but these guys are true falses. All right? Newton, any last words? All right. Well, folks, that's Newton's method. It's really not that crazy. All right? The 0 must be close to the square root of 2 here. Try those 2. Enjoy. And that's just going to go to black because it's very close to the camera. You know that, right? Okay. All right. I'll see you.